name's Boyd King with OSUIT in the air conditioning department, and I'm going to talk today about split phase motors. It's the second motor in our motor series. We've covered shaded pole motors, and now we're going to look at split phase motors. Split phase motors, we learned during the video on shaded pole motors that it takes two different inductive magnets to create a starting torque and a sense of direction. And with split phase motors, we're going to use this as kind of the platform in the next several type of motors, actually single speed non-three-phase inductive motors. We're going to build on this as our platform, meaning that we're going to see a lot of motors with a run winding and a start winding. Okay, so we know the shaded pole motor had a conductor piece of copper that was wrapped around the electrical magnet, which created a counter EMF opposing the actual flux field that was created from the winding, creating a sense of direction and starting torque. Now we actually have two wired current carrying windings of different resistance. Okay, and we can identify these two windings with our ohm meter out of the circuit. Remember, we always ohm out something out of the circuit. I have this drawn in the circuit right now, but we could ohm this out and see that we would find between two terminals a lowest resistance, and then between two other terminals we would see a higher resistance, and then between two other we would see the highest, and of course that would be the sum. If I was ohming this out, I would see the sum of the total resistance in the run winding and the start winding if I was ohming it between run and start. So if this was 10 ohms and this was 100 ohms, I would see 110 ohms between run and start. And that's a pretty common, actually, a pretty common resistance range that you might see the run winding and the start winding. Usually 10, 15 ohms in the run winding, 70 to 100 plus ohms in the start winding. Different resistances, we know through Ohm's law, influences the amount of current that can go through that winding. And more current, more induction, more flux field, more magnetic pull. So the run winding being out of phase with the start winding creates the phase angle shift that we've talked about, giving it a sense of direction and starting torque. So explaining the way that this motor would start, remember that's one of the most important parts of understanding motors is being able to explain how they start. We close a single pole, single throw switch. We have a path through the run winding and through the start winding simultaneously, wired in series with the centrifugal switch. And this centrifugal switch, you can see, is a normally closed contact. The motor gets up to 75 to 80% of its total speed. Centrifugal force on some counterweights, which I'll show you in a minute, will open this contact and take out the start winding, leaving the run winding only as an inductive load running and continuing the motor to spin. So the start winding, what is its purpose? A sense of direction and starting torque. Okay, once it gets up to speed, centrifugal force is going to open this contact. So looking at the stator of a split phase motor, I've taken one apart here. You can see the centrifugal switch contacts right here. That works in conjunction with the rotor. I'll show you the centrifugal switch on the rotor part in a minute. But what I want you to notice, inside the stator of a split phase motor, we see a tiny wire winding here, here, and here, and a fatter, more pronounced winding. Of course, the thicker the wire, the lower the resistance. Always remember that. So the bigger the wire is going to be the run winding, and the smaller wire is going to be the start winding, creating the phase angle shift. So once the rotor gets up to speed, this is of course the rotor which is spinning. As it gets up to speed, you can see the centrifugal switch has some counterweights in here that as centrifugal force starts pulling apart on these, it allows this little black disc to fall down, which would open that contact and take the start winding out of the circuit. You're going to see split phase motors. It has much higher starting torque than what the shaded pole did, but it's still not enough starting torque for applications such as compressors, but a lot of fan motors in industrial and unitary refrigeration, like in ice makers and things, a lot of the gear motors for flakers and different types of pumps may use centrifugal switches and split phase motors in there. Some of the older blower motors in residential use split phase motors, multi-speed split phase motors, but this is definitely an important motor to grasp before we move on to other multi-speed PSC motors and other type of common compressor configurations that we'll see in the field.